Hey, chemistry, this is April 3rd, Friday, chemistry class. I'm glad to see you again. I'm on page 409. Can you go there? We talked about saturated solutions on page 409. And that's when you have stuff on the bottom. For example, you don't see anything on the bottom of that. But if I put more salt than a certain amount of water can hold, it becomes saturated. It means that there's some extra sitting on the bottom that cannot dissolve. So let's take a look at page 410 and run your finger across that table at the bottom, that green table, sodium chloride, NaCl. Go over to 20 degrees Celsius temperature, then you get 35.9, which is about 36 grams of salt in how many grams of water? Look at the top of the table, and you'll see right there that it says 100 grams of water. So this whole table is built around 100 grams of water. So let me take 100 grams of water. It's currently about room temperature in here. That's 100 grams of distilled water. It says it'll hold 36 grams of salt. So let's go ahead and turn on this balance. Now I'm going to show you what 36 grams of salt looks like. I'm going to put that like that. Press the tare button. When I get to 36, I'll tell you. You watching this? There it is, 36 grams. So what this is saying is that much water will hold that much salt. If you put 37 grams or 38 grams in there, it'll sit on the bottom, the extra. So that's called saturated solutions, when there's stuff on the bottom. Now let's suppose we heat up. Let's suppose we heat up the water. Now go back to that green table again and run your finger across sodium chloride over to 80 degrees or even 100 degrees. Does the 36 become 39? Now look at other compounds. Look at potassium chloride, KCl. Would you be able to put 34 grams of KCl at room temperature around 20 degrees? But if you heat it up to 100 degrees, you can put almost twice as much, 56 grams. It's always, this table's built for 100 grams of water, which is the same as 100 milliliters of water, because it's 1 gram per milliliter. That's its density. You know that. Okay, so those are saturated. Unsaturated solutions are, they contain less solute. So let me ask, here we go. Saturated or unsaturated? Unsaturated. When I swirl that around or stir it, that stuff on the bottom gets dissolved. And I've still got some more, according to the table, that shall fit in there. But if I put it all in there and a little bit more, you'll be able to see stuff on the bottom. Now, what if I were to heat that up? If I were to heat it up nice and hot, would it dissolve it in there? Of course it would. And then I would go ahead and let it cool down slowly, very slowly, such that if I dropped 1 crystal of salt in there, the extra would just fall out, because when you heat it up, you can hold more. But when you cool it down, it can't hold as much, but it does for a little while. It's called supersaturated. It's like at this new temperature, this lower temperature, it has more salt in there than it's supposed to have. And that's called supersaturated. A supersaturated solution, page 409. is a solution that contains more dissolved solute than a saturated solution contains under the same conditions. So you got extra in there, and all you have to do is disturb it and it'll fall out. Now, the illustration I like to give is with clouds that are heavily laden with water, but they don't want to rain. They're floating over this desert where they really need water, and it won't rain, but yet they're black, indicating they're like nimbus. There are a lot of water in there. And so what they do is they fly an airplane over, and I think it's iodine crystals, that they sprinkle this cloud with iodine crystals, and that allows all those water droplets, kind of a seed, they call it, S-E-E-D, to attach to. And now you have something real heavy that falls out of the cloud that includes water. And so seeding clouds is a scientific way of getting water places that don't normally get it, if there happens to be a cloud floating by. Now I have some supersaturated crystal packets. This is sodium acetate, and it is there's too much of it in this packet than it's supposed to be able to fit in that much water. And what I do here is I snap this little coin on the bottom. And when I snap that coin, it agitates that dissolved crystal, and it will release a lot of that extra dissolved crystal out. So it will recrystallize, and you'll see it growing like a white crystal that's growing across here. Now, when that happens, all that extra heat that it took to get this thing dissolved will come out, and it makes a nice heat packet for the back of your neck while you're out in the cold. So I'll go ahead and snap it for you. I wish you were here to do that for me. Here we go. Snap. You see it growing? Growing right up there. And if you put your hand here where my hand is, it feels real warm. Put it on the back of my neck. Nice. Okay, so that is sodium acetate. And then how do you think I get the thing to redissolve? Well, I put it in some water, hot boiling water, and I boil it until it's clear. Then I lay it out on a rack and let it cool down slowly. And it goes back to this condition, where it's nice and clear, supersaturated solution. 410. What is solubility? Well, solubility is the amount of the substance required to form a saturated solution with a given amount of solvent at a specified temperature. And so what is this table down here on the bottom of page 410? It's a table of solubilities for different solutes. If you take a look, you'll see silver nitrate and barium hydroxide and sugar and calcium hydroxide and those kinds of things that you can dissolve, even some gases down there, carbon dioxide and oxygen. But you'll notice with the gases, the hotter it gets, the less you can stir into solution. It's just the opposite for all of these solids. The hotter it gets, as you go to the right on the table, the hotter it gets, the more that you can put into solution, with a couple of exceptions. So solubility of solids typically goes up with temperature, and solubility of gases goes down with temperature. If you ever take a Coke and set it out on the front step of your house in the heat of the sun, it'll go flat, because what gas comes out of it? Carbon dioxide. That's why it's called a carbonated drink. And so the carbon dioxide will come out because at a higher temperature, it can't hold as much gas. Solubility diminishes at higher temperatures, solubility goes up with solids at higher temperatures. See where it says solute-solvent interactions? That's where we're going to pick up on Monday. So go ahead and do the quiz tonight, if there is one. Check your posting.